So it says that we have a container filled with oil. The area on the left piston is 10 millimeters squared, and the area of the right piston is 10,000, so 1,000 times larger. What force must be exerted on the left piston to keep the 1,000 Newton car on the right at the same height? Well, here's the trick with these problems, these U-shaped problems, is that if we were to look at this line over here, that this pressure on both sides is going to have to be constant. So if the pressure on both sides of these is going to be constant, then we know that, the pressure is defined as the force per area. So that means pressure on side 1 is going to be the force on side 1 over the area of side 1. And the pressure on side 2 is going to be the force on side 2 over the area of side 2. And we know that these two have to be equal. So really I look at this and I get down to figuring out how much force do I need. So F1 over area 1 is equal to F2 over area 2. Or F1 is equal to F2 over area 2 times area 1. When I plug in my numbers for this, my F2, my force on the second one is going to be 1,000 newtons. I have to push 1,000 newtons up, or 10,000, sorry, 10,000 newtons up. And it has 10,000 millimeters squared down. And we're going to multiply this by 10 millimeters squared for the area of the first part. And when I work this out, I will find that F1, the force on 1, has to be equal to 10 newtons. Just have a 10,000 divided by 10,000, that's a value of 1. My millimeters cancel with my millimeters, and I'm left with 10 newtons. So in order to keep 1,000 or 10,000 Newton car from falling down, if I have this ratio of areas, I only have to put 10 newtons of force down, or 1 kilogram of weight. So if that piston weighs 1 kilogram, we're set. Or if I put a cantaloupe on there. Cantaloupe has a mass of about 1 kilogram. So kind of an interesting problem, but this is really how hydraulic lifts work. Kind of a cool little factor, but it really relies on the fact that a constant height, anywhere along this height, any point, any constant height, that entire pressure along that height is going to be the same. So I just look at the pressure at where the car is and the pressure where the cylinder is. So that's at the same height.